Hello everyone, here I welcome you all back to my YouTube channel. I am Tanushree and I am pursuing my second year BE in Sri Venkateshwara College of Engineering, Vidyanagar, Bangalore. And today's subject is gonna be about operating system. The course code is ECS303. And today's topic is memory management. So let's study the introduction part of memory management. Memory management is a crucial function of an operating system. So it involves the coordinating and handling computer memory resources. An efficient memory management improves system performance and user experience. So in memory handle, there are three types of memory handle. So firstly, we study about the compiler, which structures the address space of an applications. And then the operating system, which maps the compiler structures onto the hardware. And also the hardware, which performs the actual access of the memory allocations or the locations. Whereas we can study the next about the importance of the memory management. The proper memory management ensures that applications have enough memory to execute. It prevents memory leaks and fragmentation, which can depress or degrade the performances. Efficient memory management also enhances the security by isolating the processes. So here are the basic memory management. So first we study the memory allocation and the process address space, loading, leaking, swapping, fragmentation and paging, segmentation, memory protection and memory life cycle. So next, types of memories. There are two main types of memory, that is volatile and non-volatile. Basically the volatile memory where such as the RAM loses its contents which power is off. So next, non-volatile memory like hard drives and SSDs retains data even without power. So here are the basic examples for non-volatile memories. So we can say that flip-flop disk, contact disk, and internal and hard drive, external hard drive, flash drive, and SD card. So, which are the techniques of the memory allocation? The next is memory allocation techniques. So, here the memory allocation can also be static or dynamic depending on the needs of applications. Static allocation occurs at compile time, and while dynamic allocation happens during the executions. And common dynamic allocation methods includes heap allocation and stack allocations. Here are the memory management techniques. The two types of memory management techniques are continuous allocation and non-continuous allocation. Here are the two types of continuous allocation. One is fixed size and patrioting. One more is variable size patrioting. Now in non-continuous allocation, we can say that there are two types, that is paging and segmentation. So next, paging and segmentation. Paging drives memories into fixed size units known as pages for easier management. Whereas segmentation, on the other hand, divides memory into variable sized segments based on the logical divisions. Both techniques aims to optimize memory usage and simplify process management. So here we comes the CPU and the page number offset for the logical address. And for the main memory, here we take the frame number offset of the physical address, so we can set the table in the normal chat. Whereas we can say that the next is virtual memory. Virtual memory as also allows a system to use disk space of an extension of RAM, and also it enables a larger applications to run on the system with initiated physical memory. The use of virtual memory improves multitasking capabilities and system references. Whereas the virtual memory, two kinds of addresses. CPU uses virtual addresses, main memory uses physical addresses. Hardware translates virtual memory to physical addresses via an operating system OS, managed stable to the page mapping also. Here are the few examples of the CPU, MMU, and also the DRAM, CPU, and also the disk. So the next concept is about the memory protection. Whereas the memory protection ensures that the one of the process cannot access the memory space of the another. And also this is the crucial for the maintaining system stability and the securities. Protection mechanisms include access control and address space, layout randomization. So here the memory protection is implemented by associating and protection bits with each frames. Valid invalid bit attached to each entry is to page tuple, where the associative page is the process logical space and read and write. So here we go for the fragmentation issues. Fragmentation occurs when memory is used inefficiently, leading to wasted space. These are the two types of external fragmentations and also the free space of stacked throughout an initial fragmentation and shared memory within allocated blocks. Strategies like computations from migrate fragmentation efforts. So here has the flowchart for the fragmentation issues. So the next concept is about the role of memory management unit, that is MMU. Whereas the memory management unit, that is MMU, is responsible for the translating virtual addresses to physically addresses. So it plays the key role of implementing paging and segmentations, and the MMU ensures the memory protection and references rights and efforts. Here is the flow chart for MMU, that is CPU, that it moves through the logical addresses and it reaches the relocation registers, that is MMU, that is 14,000, and it throughout continues to the physical addresses, that in 14,346 to the memory. And the last concept is about the future trends in memory management. Emerging technologies like non-volatile memory ensures the NVMe are changing memory management landscapes. Machine learning algorithms are used to exploit for optimizing memory allocation. Future operating systems may leverage advanced memory management techniques to ensure performance and efficiencies. So, the basic references for the concept is about Lizchat and Ham Peter Glavin, and also the operating system concept Willet and 2018. If you like the video, please like, share, and subscribe the video. Thank you, everyone.